RMI architecture stack and participating classes interfaces in RMI client server programs in Java remote method invocation. Here you can see RMI architecture stack and participating classes or interfaces in RMI client server programs. As RMI is an action of invoking method of a remote object from another address space, JVM, or machine, its characteristics differ from local method invocation. We analyze the characteristics which differ in local method and remote method invocations and how RMI implementation RMI implements these characteristics. The RMI architects try to make the use of distributed Java objects the architecture is built using 3 layers. Stub and skeleton layer, which lies just beneath the view of programmer. In this layer, RMI uses proxy design pattern, remote reference layer, which connects clients to remote service object, running on server machine. Transport layer, which provides basic connectivity between JVMs. The comparison of you can compare RMI layers with the comparison of RMI layers with OSI layers shown in this figure. We have also identified the participating Java classes at each layer of Sun RMI implementation. Each layer of RMI implements its own interface. These layers are independent of each other, so can be replaced by other implementation without affecting other layers. The basic components in any RMI applications are interface, RMI server program, RMI server program, the basic components in any RMI applications are interface, RMI service program, RMI client program, stub, skeleton, and RMI registry. Before a client can use a remote service object, the remote object must be instantiated on the server and exported to RMI registry. The RMI server program will bind the remote service with RMI registry. The interface and remote service, the RMI architecture separates out the definition of behavior and implementation of that behavior. The code that defines the behavior and the code that implements the behavior are separate and run on separate JVMs. The definition of behavior is given by the interface, and implementation of behavior by Java class. In Java, it is responsible to have two implementation classes of the same behavior interface. RMI supports two classes that implement the same interface. First class is the real implementation of the behavior, which runs on the server machine, called the remote service object. The second class acts as a proxy for the remote service and runs on the client machine. Stub skeleton layer. RMI uses proxy design pattern at this layer. Using proxy design pattern, object in this in one context is represented by another proxy in a separate context. A stub is a client-side proxy for remote service object. Server-side proxy is known as skeleton. The stub understands how to communicate with the skeleton across the link. Stub intercepts each method call by client to remote service. The stub provides functionalities of one, carrying out conversation with skeleton, 2, marshalling of argument, 3, marshalling out result, for providing result to the client program. The skeleton understands how to communicate with stub. Skeleton is responsible for carrying out conversation with stub, reading and unmarshalling parameters for the method call, delegating the call to the remote service implementation, accepting and marshalling the return value of call, sending the result back to the stub. Remote reference layer. Remote reference layer handles semantics of invocation. JDK 1.1 implementation of RMI provides only unicast, point-to-point, and connection between client and remote service. In JDK 2, this layer is enhanced to support the activation of dormant remote objects. When a method call is made by a proxy client, the RMI determines if the proxy service object is dominant. If the dormant RMI will instantiate the object and restores its state from disk file. Other types of communication semantics are possible. For example, using multicast semantics, a single proxy could invoke multiple remote services in replicated objects. Transport layer. Transport layer provides basic connectivity between JVMs using stream-based TCP network connections. RMI uses Java Remote Method Protocol, JRMP, RMI specification 1999, wire protocol on top of TCP/IP. JRMP is a proprietary protocol. The first version of JRMP, which was released in JDK 1.1, requires the use of skeleton classes on server side, whereas the second version released with JDK 2 has been optimized for performance and it does not require skeleton classes. This layer is responsible for setting up connection to remote address space, to managing and monitoring the connection aliveness, 3, listening for incoming call, for multiplexing multiple virtual connections with single TCP connection. Direction of internal working of RMI. Possible enhancements and implementing authentication is in standard RMI, Java RMI. Here you can see RMI client an RMI server here. Here you can see client program and server program. Here RMI client stub, here server skeleton. Client stub, remote object and remote stub are in client stub. Here client stub, remote stub, remote object, and remote stub in server skeleton. Here you can see below that client stub interacts with the remote reference layer, and server skeleton interacts with remote reference layer. Remote ref, unicast ref, unicast server ref, and live ref are in remote reference layer. Remote reference layer interacts with transport layer. Endpoint channel, endpoint channel, TCP endpoint, TCP channel, TCP connection, and TCP transport are inside transport layer. Here the you can see OSI layers. Client program and server program are in application layer. Client stub and server skeleton are in presentation. Remote reference layer and is in session, and transport layer is in transport. Here transport layer of client, RMI client interacts with transport layer of RMI server. Now this is the end of my presentation. Thank you very much for watching it.